Hey guys, welcome back. Today we are continuing our unit in stoichiometry. Just like yesterday's lesson, today's lesson builds on what we learned yesterday. So if you are behind in this unit, you have to go back and do lessons 1 and 2 first. You can't do this without having the concepts of the first 2 lessons, okay? So with that out of the way, let's go ahead and get started. Today we are learning how to do percent composition. And now thankfully, this concept today isn't as difficult as the conversions that we've been doing the first couple days. So hopefully this will be a little bit easier and not take as much time today for you to do. So really quickly, if you took a test, could you figure out what your grade would be if myself or Mastery Connect didn't tell you? So like if you got to the end of Mastery Connect and it didn't tell you what your percentage was on your test, could you figure it out if you knew how many you got correct? Well, the answer to that should be yes, because that's just a basic percentage. So whenever we're doing percentages, just a review, you would take the total number of questions you got correct. You would divide it by the total number of questions there are, and then you would multiply it by 100%. Okay, so that's just a simple percentage problem, and that's going to be what we're doing today. So, for example, if you got 20 questions correct on your test that had 25 questions on it, what would your score be? Well, again, we're going to take the number we got right, so the partial, over the whole, which is 25, and multiply by 100. So 20 over 25 times 100 would give us 80%, and that's how you do basic percentages. Again, should be a review because you guys are juniors. You've been through lots of science and math courses at this point, but that's just a review of how to calculate percent. Okay. Also, we need to make sure we remember what molar mass is. So yesterday we learned that molar mass is determined by adding up all the mass for all the atoms in a compound, right? So the mass for the individual atom comes from the periodic table. It's the average atomic mass. But to get the molar mass, we have to make sure we're adding it for however many atoms are in the compound. So like, beryllium here is 9.0122, but if you had 3 beryllium in the compound, you would have to do 9.0122 times 3 in order to get the total molar mass. So we just got to make sure we're counting our atoms correctly and we're getting our average atomic mass from the table. All right, so now let's talk about percent comp. So just like our score for the test, we can determine how much of an element is in a compound. So like if we're looking at like sodium chloride, we can say, okay, this percentage of this compound is sodium, or this percentage is chlorine based on its molar mass. So here's how we do that. We have to find the mass of the part, so AKA the molar mass of the element we're looking for the percent comp for. We have to find the mass of the whole, so the molar mass of the entire compound. Then we have to divide and multiply by 100, so just like a normal percentage. So the mass of the part, like when you're calculating on your test, you got 20 right. The mass of the part would be the atomic mass of the element you're looking for. The mass of the whole, the mass of the entire compound, and then we just divide and multiply, okay? So the percent composition is the same if you have a gram of the compound or a truckload. So it doesn't matter how much of, whatever compound that you have. You could have 1 gram, 100 grams, 1,000 grams, 10,000 grams. It doesn't matter. The percent composition will be the same. So that's really nice. So then now let's take a look. What is the percent composition of sodium chloride? Whenever you see this, what it's asking you is it's basically saying, if we have this compound, how much of it is sodium and how much of it is chlorine? Okay, so we're going to have to do this process for both of these elements. So first things first, we have to figure out the part, right? So sodium, that 23, where does that come from? It comes from the table, okay? So your periodic table. So remember, sodium, it's got its average atomic mass is 22.990. We just rounded to 23. And then chlorine is 35.45. I'm assuming we're going to round to 35. Okay, again, molar mass is coming from the table. You have to find it in the periodic table. So we have 23.0 for sodium. And then chlorine is 35.5, so we're rounding to 3 spaces here. And so that will give us our molar mass of 58.5 grams. So here we have found the weight of the individual and the weight of the total. So sodium is going to be 23 grams, that average atomic mass coming from the table. Chlorine is 35.5 grams. 35.5 plus 23 is going to give us 58.5 grams total. Okay? So that molar mass, again, you will need to calculate. And this is the total mass that's going to be the compound, or of the compound that's going to be on the bottom of the fraction. Okay, so let's do sodium first. What's the percent composition of sodium chloride? How much of sodium chloride is just sodium? So we're going to take 23.0 grams. We're going to divide that by the total mass of the compound, which is 58.5, times 100 gives us 39.3%. So in sodium chloride, the compound sodium chloride, 39.3% of that compound is sodium. Okay, now let's do chlorine. So 35.5 is going to be our part of chlorine, so 35.5 grams, divided by 58.5, which is the whole, times 100 will give us 60.7%. So that means 60.7% is chlorine, and then it was 39% sodium. Now we're rounding here because we're using average atomic masses, but this makes sense. So sodium is around 40%, chlorine is around 60%. 60 plus 40 gives us 100%. So again, what this is saying is in sodium chloride, 60.7% of it is chlorine. Okay? So let's do a few more examples here. So here we have aluminum oxide. So we've got 2 aluminum and 3 oxygen. Okay, so we're going to need to find the mass, the molar mass of the aluminum, the molar mass of the oxygen. We're going to have to add it all together, and then we're going to have to divide. Okay, so again, aluminum, we got to find the average atomic mass from the table, which is 27.0 grams. Okay, and again, that's coming from the periodic table. You find it in the average atomic mass. Again, this is not going to be precise. We're going to be rounding. So as long as you guys are coming up with answers that are close to the correct answer, you'll be fine. Like you could be, a few decimals off and everything will be okay. So we have 27.0 is the average atomic mass of 1 atom of aluminum. We have 2 here, so we have to multiply by 2. So the total in this particular compound is 54. So in aluminum oxide, the aluminum weighs 54 grams. Okay, now let's look at the oxygen. The average atomic mass of 1 atom of oxygen is 16 grams, but we have 3 in the compound. So here we have 48 grams of oxygen in this particular compound. Okay, 54 plus 48 is 102. So 102 grams is going to be the number we use for the bottom of the fraction. Okay, so now let's calculate. So aluminum, 2 atoms of aluminum is 54 grams, that's the molar mass, divided by 102 times 100 is 52.9%. So 52.9% of the compound is aluminum. Now, right off the bat, we can tell my oxygen, if 53% of my compound is aluminum, 47-ish% is going to need to be oxygen, okay? So the weight of 3 oxygen atoms, or the molar mass of 3 oxygen atoms, is going to be 48 grams divided by 102, because again, the bottom number will always stay the same because it's just the total mass, times 100 is 47.1%. Perfect, which is exactly where we want to be, which gives us 100% for the total. So in aluminum oxide, 52.3% is aluminum, 47.1% is oxygen. These are pretty simple. Where students run into a lot of issues is forgetting that to calculate the molar mass, you need to account for all the atoms. So sometimes, they'll just take the average atomic mass from the table, and then it gets wonky because you're not taking into account the number of atoms there. Okay? Let's do one more So here we have silver hydroxide. Now I can tell there's no subscripts, so we are actually going to use the average atomic mass for each of these because there's just one silver, one oxygen, one hydrogen. So silver is 107.9 grams. That's that average atomic mass from the table. And again, that's going to be the larger number in your element box. Let's just go ahead and go. I know at this point you guys probably know how to find it, but just in case, again, that number is coming from the bottom here, that 107.87. So 107.9, and then the total is 124.9 times 100 is 86.4%. Okay. Did I skip a slide? Hold on. Oh yeah, I did. Oops. Sorry guys. 107.9 times 1 is 107.9, so there's 107.9 grams. There's one oxygen, which is 16, so there's 16 grams of oxygen in this compound. And for hydrogen, hydrogen is just 1 gram, so that's the average atomic mass. There's one of them, so there's 1. So 107.9 plus 16 plus 1 will give us 124.9 grams. And that will be what we use in the bottom fraction for each of these. All right, now let's do our percent comp. So for silver, we're going to take that part, 107.9, again from our average atomic mass, which is our molar mass in this case, divided by 124.9 times 100 will give us 86.4%. So in silver hydroxide, the silver composes 86.4% of the compound, which makes sense because it is the heaviest, right? All right, and then for our oxygen, 16 divided by 124.9 times 100 will give us 12.8%. So in this compound, the oxygen makes up a roughly 13%. And then for hydrogen, it's going to be a small number because there's only 1 gram. It's going to be 0.8%. And 86.4 plus 12.8 plus roughly 1 is going to give us around 100%. So that makes sense. So the good thing about this is that you can kind of easily check yourself. So if you get to the end and your numbers do not add up to 100% or very close to 100%, it might be, 99.5, maybe 100.2, depending on how you're rounding. But you should have around 100% for each of them. And that's a good way to check yourself. Okay. So percent composition, the biggest thing is number 1, pay attention to how many of each atom you have in the compound, because so like for example here, if you had like a 2 behind this oxygen, you would need to do 16 times 2 because you need to make sure the molar mass is correct. So you're going to calculate the molar mass for the entire compound and then for each of the elements as well. Then you just take the part, divide it by the whole, and times 100%. So these are a little bit easier than the conversions, but the biggest thing is going to be making sure you're getting the correct molar mass. So again, if you didn't watch yesterday's lesson, you're probably a little bit lost on molar mass. So go back and do that first. You guys are good to move on to your assignment today. And if you have any questions on this, just let me know.